Welcome back, everybody. We're continuing our study in the solar system. We've looked at the rocky planets towards the sun, and now we're going to look at the further planets, which are not made of rock or hard material, but more just gases, different types of whirling gases inside. But just because they're gases doesn't mean they're not enormous and massive. They're massive. So Jupiter is the biggest planet. Okay, so we now have gotten to Mars, and then the next planet out is Jupiter. There is more material in Jupiter than everything else in the whole solar system other than the sun. In fact, it is 2.5 times bigger than all the other planets, all the asteroids, the comets, everything that is in the solar system. Jupiter is bigger. Okay, it is swirling around ridiculously fast. So its day is only 10 hours long. So it is going around so fast, it would be just like the worst amusement park ride that you could imagine, just how fast. In fact, it's going so fast, and its atmosphere is swirling so much that you can see bands on it, where you've got dark bands where the air is sinking down, and then you have lighter bands where the air is rising up and swirling. You even have an enormous hurricane that is in the southern hemisphere of Jupiter that has been there for at least 300 years, because that was the first time someone has ever made a recorded comment about the spot that they could see on Jupiter. So you've got just bands of swirling gases. It's pretty amazing that it has so much gravity that it actually protects Earth a lot. It's very close to Earth. It's just, between, you have the asteroid belt and Mars and then Earth. And Jupiter is so big that it often will pull in asteroids that could be headed towards Earth. Really big, dramatic explosions on the surface as the gravity pulls it in. Picture on the left is these bands. You see you have zones and bands. The zones are bright clouds where the air is rising and getting bigger and cooling down. The belts are this area of the atmosphere that is sinking, getting denser, and you add to it that this thing is going around huge planet going around all the way around its axis in 10 hours. You end up just with swirls. It would be almost like making a tie-dyed t-shirt where everything is just swirled around. Okay, you can see that there are volcanoes. Interesting, since there's not actually ground as such, but you do have such matter there that's pressed in so tight that you have some enormous explosions. So this is what is known so far about Jupiter. You've got liquid hydrogen, okay? So ridiculously cold. Liquid hydrogen on the surface. So you have a surface ocean of liquid. If it's so big and the gravity is so intense that you couldn't stand on this planet. First of all, it has a liquid ocean gas on the inside of that, and it would just squish you to a jelly because you couldn't stand up because the gravity would just squish you to the ground. About halfway in, the pressures change, and you end up with a new hydrogen inside. So most of this is hydrogen and helium, almost the whole thing of Jupiter. Then as it goes in further, you're going to get a metallic hydrogen, okay, whatever that means. Metallic hydrogen meaning that it's acting more like a metal than it is a gas. Now, if you remember that a star, this could have been a star if it was bigger, 10 times bigger, and it would have glowed like the sun, because the sun is made up of hydrogen and helium also. So there's a lot of dispute here, but it's possible that there is a core that has at least some rock and metal in it, because just because of where would that metal go? It would go to the inside. If it were crash in, so even an asteroid crashing in, where would it go? It doesn't just sit. It would keep floating down further to the core where the denser material would be. There are 4 moons. You're going to see that there's 16 moons at least, probably more than 16. 4 of them was spotted by Galileo using the first telescope that we ever had. And he looked at Jupiter, and he saw that there were 4 moons circling Jupiter. And this was one of the evidences that he saw that made him believe that the Earth was a planet and not that everything revolved around the Earth, but the Earth was going around. If our moon goes around our planet and Jupiter has moons going around it, it just gave him that thinking that Copernicus had the right idea. These are all named famous mythological things, Shakespeare and Greek myths. Callisto, Europa, Ganymede, and Io. You're going to see a lot of these are the size of Earth's moon and have almost inhabitable planets of their own. The size, they're so big, but they're tiny compared to Jupiter itself. Okay, so here's the original Galilean moons. You have Io, okay, there's volcanoes, just like Earth has volcanoes. This is a moon that has volcanoes. Europa is the small one, icy one. Ganymede is the huge one, okay? Crater, just like the moon. And then Callisto, and it has lots of craters. You can see it speckled and pockmarked, just like Earth's moon. The next planet is Jupiter. If you were to take, Saturn, which is next after Jupiter. If you were to take Jupiter's, how far Jupiter is away from the sun, Saturn is that much further away from Jupiter. Okay, so there's just enormous amount of space in between Jupiter and Saturn. It's similar in that it has a dense atmosphere. Its composition is gases, liquidy, gassy, not a lot of rock there. Possible internal structure too, like where the dense materials would go to the middle. The most famous is that it has rings. The rings are ice crystals so bright that you can see them with a telescope. I've looked at the rings of Saturn just with a not very expensive telescope. Okay, you can see them quite easily. What nobody knew is that a lot of these other gas giants also have rings. Jupiter has rings, Uranus has rings, Neptune has rings. All of them have these kind of ring structures that no one saw because you can't see them at this distance. It took a space probe going there and taking close-up pictures to realize that they were. The rings aren't solid, but they're basically like a whirring gas and ice crystals that are vaporizing and kind of smearing around, and you get it almost like the grooves of a phonograph record. You're going to see that Saturn's rings were so easy to see that even they saw them in the 17th century. You can see that it's actually a ring system. There's numerous rings, all in kind of stripes around Saturn. You also see that Saturn also has these bands, very much like Jupiter did, because it's whirring at such a pace, and the atmosphere is thick, just like Jupiter's. So you end up with even little blue dots. You can see a blue dot here, where there are storms, just like Jupiter storms. Now, the Jupiter storm that we saw a minute ago, that red spot, you could put 2 Earths side by side in that red spot. That's how big that Jupiter is. Saturn doesn't have that much of drama, I guess. About 16 other moons were found, some of them so small, and some of them even going in the other direction. All of them are spinning in one direction, and a lot of these little moons going in the other direction. So to where that came from or how that happened, no one knows yet, but lots of speculation. Sometimes the stripes in the rings are actually caused by a moon that's basically all of the debris kind of running into that moon and making a stripe in the ring. Uranus and Neptune are almost identical in terms of size. They're about one degree difference in diameter, And they're very similar in how what they're made out of, and their atmosphere, etc. Uranus is sideways. So instead of spinning where the equator is lined up with the sun, and the equator is always going around the sun, the pole is going around the sun. It's moving around the pole, and the pole is facing the sun. So it's spinning one direction and revolving in another direction, which would probably make all of the people that live there very carsick. I forgot to mention on the last lecture that Venus is also weird. Venus rotates backwards. It has retrograde motion. It's not spinning in the same direction as all the other planets are spinning. And Uranus is like Venus in that it is rotating sideways. We see through the space probes that they also have rings and lots of moons. A lot of these gas giants have moons, and many of the moons are terrestrial, like rocky moons. So the Neptune, what you know about Neptune is it's blue. When you look at it through a telescope, it's bright blue, and it has lots of clouds. That's why you can see it very well, and serious winds. So fastest winds in the solar system. All of these gas giants have moons. Some of them have volcanoes and things on them, like you would imagine Venus does, or Earth does, or Mars does. And they have ring systems too. It took a space probe going there to find that out. So this is cool. You see the ring is sideways too. Whereas Saturn's rings go around its equator, Uranus's rings go around its poles. So it's just wacky. Triton is Neptune's moon. Okay, I think that's where the Disney movie got Triton. Triton is the moon of Neptune, and Neptune in Greek mythology was actually Poseidon. So in Roman mythology was the god of the sea. And so this is the largest of the moon, and it goes in opposite directions of all the other planets. Pretty weird. Lots of volcanic activity and lots of solid nitrogen, methane. It's just cold. So what is gases on Earth would not just be liquid, but be solid on Neptune. So it's just a frozen blue planet. Now we know that they have rings, and somebody named them, I'm sure, after themselves. There's also a great spot, and there's cirrus-like clouds. So you've got an atmosphere, you've got big white fluffy clouds in there, and then you have these swirling storms, similar to what we saw on Jupiter, but just harder to understand because it's just so far away. These are billions. It takes billions of miles to get a space probe out there to see what is going on, and so there's still a lot of questions.